Today we're going to talk about rational exponents, also known as fractional exponents. Let's start with something simple. Let's look at the radicand when it's raised to the power of 1. So we'll start with our radical symbol, and then we have our index here, which we'll call n, and our radicand, which is inside the radical, called a. And if it's raised to the power of 1, we can rewrite this as a fractional exponent is a to the power of 1 over n. Let's look at the different parts we're examining. First, we start off with the index. And the index is right here. That is equal to our denominator of the exponent. And we see 1, which is our exponent, is now our numerator. And a is what's called our radicand, which is what is inside the radical symbol. Let's try some examples. Let's look at these first two problems. These are both in radical form, and they both have an exponent of 1. So let's rewrite our equation. If you remember, we have our radicand, which here is 16, raised to the power of the exponent, which is 1, over the index, which we know is 5. So to go from radical form, which we have right here, to exponential form, we take the radicand and we raise it to a fractional exponent. I'll give you a couple seconds to try number 2 on your own. Okay, once again, we're going to start with the radicand first, which we see is 108. Then we take the exponent, which here is equal to 1, over our index, which we see is right here, 3. And there we have it. We have the cubed root of 108 written in fractional form. Now let's try to go the other way. We'll go from exponential form to radical form. So now we're going to try some examples that are in the exponential form first, and we're going to put them into the radical form. Let's start with number 1. If I have 27 to the 1/3 power, remember I'm going to draw my radical sign. My radicand is my base, so it's going to go inside the radical symbol. 1 is the exponent that 27 is being raised to. And 3 is my index, which goes outside of my radical sign. And that would be your final answer. Let's try one more. Once again, start off by drawing your radical symbol. Your radicand is your base, so we know that where 8 is going to go in the radical symbol. It's raised to the first power, which I'm not going to write in here because we know it doesn't change anything. And lastly, my index is 4. Both of these examples on these past two slides have used an exponent of 1. Let's see what happens when our exponent is no longer equal to 1. When dealing with rational exponents that have an exponent greater than 1, they can be written in this form. We draw a radical symbol, we have our index, and our base, which is being raised to the exponent of m. And our base is also called the radicand. This can also be rewritten as radical symbol with our index, our radicand, all being raised to exponent of m, which written in fractional exponent form is a, which is our base, to the power of m divided by n. So remember, once again, a is our base, and here it is called our radicand. Here we have our index. And here we have our exponent, which same as we saw before, exponent was our numerator. And our denominator was our index. Let's try some examples with this. Let's first start by simplifying radical expressions and rewriting them as with rational exponents. So here we have the fourth root of 32 squared. So first I'm going to start by taking my radicand, which we know is 32, rewriting it as my base. And now I know that my exponent is the numerator and my index is the denominator. You can leave it just like that. Let's try another example together. So here, kind of similar problem, just written into a different format. Same steps. Take the radicand, which is equal to 32, rewrite it as your base. Take your exponent, the power that the radical is being raised to, which here is 3. Write that as your numerator for your fractional exponent. And then the denominator, once again, is your index. And we'll write the denominator as 5. So here we have 32 to the power of 3/5. Let's go the opposite way. Here we have two separate expressions with rational exponents. Let's go ahead and see what we can do with this. So let's go ahead and set this up. First I'm going to draw my radical symbol. My base is n to the 4th. This is all being raised to the 3rd power, which I'll put outside. And my index is 2. So the square root of n to the 4th, which we're not done yet, is n squared. And we still have to cube that. And remember, this is a power to power rule, so 2 times 3 is 6, so we get n to the 6th power. Some of you guys might be saying, well, how did you get n squared? Well, let's go back one more step. And we said that we're trying to find the square root of n to the 4th, which is the same thing as n squared times n squared. So since they're the same thing, we can say the square root of n squared, n to the 4th, is just n squared. Okay, go ahead and take a second to try the bottom one on your own, and we'll talk about it in just a second. Okay, so once again, let's go ahead and set up our radical. Inside we have our radicand, or our base, which is 64 m to the 4th. This is all being raised to the 3rd power, as we see from our numerator. And our index is 2. So we can go ahead and try this problem out. We know the square root of 64 is equal to 8. And the square root of m4 is m squared. This is all being cubed, though, so we're not quite done yet. And we know that 8 cubed is equal to Well, I'm not 100% sure. So right now, if you don't have your calculator out, definitely might want to pull that one out. 64 cubed, we have a 512. And then it's power to power rule for the 2 and the 3. So we get m to the 6th power as our final answer. On the next page are several examples. Go ahead and try them on your own, and we'll talk about them in class. Here are some problems to practice on your own. You're going to go from radical form to exponential form, and from exponential form to radical form. Please make sure you try out each one of these. That way you understand how to do them and what you're working with. Also on Google Classroom, there is a PowerPoint that I want you to go look at. Make sure you take some notes from the PowerPoint. I will not be going in depth into the information on the PowerPoint, but we will be using it to solve some of the problems that we're working with. Go by, take a couple quick notes, and we'll go over the examples in class tomorrow.